Hello and welcome to another episode of Impulsive Compulsion here at Question the Truth with me, Slisk Lindqvist. And today, well, I saw a video. I usually look at a lot of different videos, but this time, well, I got irritated, as I usually do. Can always tend to get a bit irritated when it comes to some videos and whatnot. But yeah, so there's these, well, there's these tablets, clay tablets, that are older than the Bible, and they're really interesting. And there's one channel that's been making have combined all the different theories that is out there to, well, the different theories surrounding the clay tablets and the stories that they tell, and it's interesting. It's a lot of hours to look through, but one thing in particular, that I reacted to, which I tend to react to all the time, is this misconception of water being water expending when it gets warm, which is hilarious, really. So let's take here water expansion and compression. This is what I'm going to talk about in this episode, and I'm going to use different YouTube videos because I'm too lazy to make the experiments myself, and handling some of the things is a bit how should I state it, idiotic. But yeah, I'm gonna start off with the idiotic video after this video. So let's start here and listen to him.
Of our technology and most of civilization, being reduced to a level of consciousness where we had to start over technologically from scratch, with no records and very little evidence of any ancient civilization. This entire story is said to have happened 13,000 years ago, at the point when Earth went through a huge shift pertaining to its polar ice caps, when a massive amount of ice sheets began to melt, flooding the world with water.
No. And this is when science comes into the picture. This is when his channel kind of swirls into something that I would not hesitate to say fictional. Oh, so let's take that little moment there again.
Polar ice 13,000 years ago, at the point when Earth went through a huge shift pertaining to its polar ice caps, when a massive amount of ice sheets began to melt, flooding the world with water and potentially helping to usher in the hollow.
Yeah. Okay. This is not gonna work for me. So, let's see. Where is that? There it is. Let's now take this instead. Which one was it? Nope. Okay. Where is... Oh, it should be this then. Yeah. This is the one I'm thinking of. So let's start with this. I've sped it up to
something a lot of people might be thinking about this time of the year. Frozen pipe
times 2.
How it expands and can really just show the force of water turning to ice. Go ahead.
Absolutely. So we got a bucket of ice here, and like you said, ice or water when it freezes expands, which is unusual. Most things shrink when they get cold.
Yeah. I should turn that speed to normal.
And how it expands and can imagine it along with Carl Nelson. And today, dealing with something a lot of people might be thinking about this time of the year, frozen pipes, the power of ice, and how it expands and can really just show the force of water turning to ice. Go ahead, Carl.
Absolutely. So we got a bucket of ice here. And like you said, ice or water, when it freezes, expands, which is unusual. Most things shrink when they get cold. But water expands. So let's demonstrate that. Go ahead and throw some ice.
You heard right there. Water expands. And if everything is equal and opposite to, well, let's just go to this.
This demonstration shows that melting ice in water does not cause the water level to rise.
You can clearly see what happens when you put water into a closed container and leave it in the freezer. When it turns from water into ice, it expands, and in this case, breaks the container. And I have a little blue iceberg here that I'm going to float in a volume of water. And by the way, icebergs have a bluish tint because ice tends to absorb a little bit of a longer wavelengths, like towards the red end of the spectrum, and so what's left is blue. I'm going to fill this up to nearly overflow. Capsize the iceberg. Okay, settle down. I'm going to fill this up to nearly overflowing. And what might be surprising to some of you is that as the ice melts, the volume does not increase of the ice-water combination, and so none of the water will spill out. And that makes sense if you realize that as the water melts, its density increases because it's turning back into liquid water. And so it all makes nice mathematical and physical sense. So we'll just let it sit there for a while, and we watch it on the clock. Water is the only material that occurs naturally on Earth in all three forms, gas, liquid, and solid.
Yeah, and it's melting, and it's still not, it's wet down here, right? You can see there's no water sipping over the edge at all.
Okay, so here the ice is gone, and we've got no spillage whatsoever. Thank you, and come back for another Dr. C.
That's that video. Okay, so we concluded that water does not expand when melting. Okay. This here is multiple things that has to do with temperature and how water is different from other things. And I don't have any sound on it because it was music and it was irritating. But you can see here it's expanding and it's, yeah, cracking the bottles and stretching the caps. This here heats a ball. You can see it go in and out. And now it can't go in. There. So he cools it. No, missed it. There, he cooled it. We have also this. This is interesting though because it has to do with air. Warm, hot water on the left and water with ice on the right, which is cold. And it makes the air or the oxygen expand and compress, which is interesting. I haven't seen past this part and I don't really need to see more of it. We have here.
Hello, welcome to Everything Fact. Make sure to subscribe and hit the notification button.
Below 4 degrees Celsius, the hydrogen bonds between water molecules become stronger and cause the matter to expand. Because the bonds between water molecules are stronger, they are less likely to break and reform as they do in the liquid state. As a liquid, water molecules are constantly moving, forming and breaking hydrogen bonds, resulting in less expansion. When frozen, water molecules take a more defined shape and arrange themselves in six-sided crystalline structures. The crystalline arrangement is less dense than that of the molecules in liquid form, which makes the ice less dense than the liquid water. When water freezes, volume expands by approximately 9%. When water molecules are in the liquid state, hydrogen bonds are continuously being formed and reformed in a disordered fashion. The average amount of H bonds a water molecule has at 25 degrees Celsius is 3.4 bonds. During freezing, water molecules lose energy and do not vibrate or move around as vigorously. This allows more stable hydrogen bonds to form between water molecules, as there is less energy to break the bonds. Because of the crystal lattice structure imposed on water molecules once the freezing point is reached, the average H bonds per water molecule is much closer to its maximum for bonds. The orderly, crystalline way in which the hydrogen bonds form causes density to decrease, because each water molecule is held away from its neighbors at a distance equal to the length of the hydrogen bonds. Thus water expands as it freezes, and ice floats atop water. This property is crucial to life as we know it. Ice sheets on the surface of the ocean insulate the water beneath and allow organisms to live in polar regions of the world, and also prevents oceans from freezing solid.
Prevents things from freezing solid. Okay, the whole ocean from freezing solid. That's interesting. Next, we're going to continue with this one. Or rather, we're going to do this one first, I think. Yeah. We don't need sound for this one. And it's already sped up. Basically, he's filling the balls with water. So there's just tiny bits air in the balls. And then he's filming it in minus 18 degrees. So you can see how the ice or the water is turning into ice and then expanding and then expanding. And then we have the last one now, which is the power of ice, what it's
glasses of water
capable of doing,
let's see how it floats.
but also the
Throw it in the other one as
stupidity
well.
of how he's handling this
A little bit of a
substance,
fake out here. This one is
or
actually
how
ethyl
these two
alcohol.
people
Okay.
are
Okay.
handling
Ethyl alcohol. So the ice is
substances
more dense,
on
that's what sinks, but in
on
water,
national
the ice will
TV.
float.
On
And that
American
expanding
national
property,
TV,
taking up
you
more
can see
space,
here,
is a real
ABC.com.
problem if you store your Pepsi
This
cans
is a
in the freezer.
national
Right? You're gonna,
TV
that happens,
program
sure.
it's gonna pop open and make a
of
horrible mess.
American TV.
But also,
blah, blah,
even
blah.
worse would be
But
cast iron
how
pipes
they're
in your home, or any
handling
kind of
this,
pipe, really,
if
where
you
it's a
would
closed volume,
were to
as
see
that
a
ice begins to freeze
scientist
and it
handling
expands, it can rupture
nitrogen
the pipes.
You'd think that'd be
You would think this would be
it'd be last
nitrogen.
forever, but
You would think.
even
Liquid
though
nitrogen.
we're just changing water to ice, it can break something that strong.
And when water changes to
They
ice,
would
it
not
expands by about
handle it
9%.
in the way
and in a
that they
closed
are
volume
doing
that can
because
generate
it
over 1,000
basically
atmospheres of pressure.
instantly
Tremendous
freezes
pressure. So we're going to do
the
it.
skin.
Okay.
Let's go.
So
and
what
can
we're going to do,
actually
we're going to
hurt
use
you.
not ice
or
to cool
hurt
this
the
down, but some
nerves
liquid
and
nitrogen. Okay.
Well,
Which
But
is
it's
basically
320 degrees below zero. Very,
have
very cold. But
you,
first we need to get this filled up all the way with water. With no
sorry, I
bubbles
should do
inside.
this so I can be heard properly. Basically, we don't even need any sound. But yeah, how they are going to handle the liquid nitrogen now is the most stupid thing you could ever do. And I'm like, okay, it's squishing over. It's cold. This is cold. Liquid nitrogen is so cold that it starts boiling in it starts boiling in normal room temperatures, and he's just dropping it. What happened here is that the pipe, iron pipe, bursted. It popped. The water expanded and it made a crack in it, something like the one that he's holding there. And that's a very destructive power of water. But it should also teach you that water expands when it gets cold, and it compresses, and ice compresses when it becomes water. So we will not be swimming in the ocean when all the ice in the world all the ice in the world melts. It's more likely that it's gonna be more humidity in the air. Probably it's also going to be more difficult to breathe, since as I showed you in an earlier video, oxygen expands and compresses depending on temperature. And yeah, now we go into racial we can go into biology now also. It shouldn't be in this video, but yeah, some people have big noses and others, like us in the north, have small noses. It's so that we can take up the equal amounts of oxygen as each other, but the oxygen in the north is more cold, so it's more compressed than the one in, say, Africa or Australia. Now it's something that takes... This is something that happens over a very long time, so it's not like, oh, I'm going to Africa now and boom, my nose is super big. No, sorry, I didn't mean anything negative about that, but yeah, okay, it's just something that people should think of. Anyway, thanks for watching, and well, have a good see.